All right, in the last video we showed the properties of the Laplace transform, and now let's go through some of those properties and let's do an example too. But the time differentiation is the most important property because it transforms differential equations into algebraic equations. So if I take the Laplace transform of differentiation, let's say we've got a function f and it's differential, what does that mean? Well, it turns out it's s times the Laplace transform of f minus f evaluated at 0. So where does that come from? If I look at the definition, the Laplace transform of f prime is the integral from 0 to infinity, by definition, of e to the minus st, the kernel function, and then let's put the f prime of t over here, dt. Now, this is integration by parts. We got the integral of u, and then let's dv. The integration by parts, if I integrate this by parts, I've got the integral of u dv equals u times v minus the integral of v du. So if I do that here, the right-hand side here is uv, so u is just e to the minus st, and v, if I integrate f prime, I just get f of t. And then I'm going to evaluate this from 0 to infinity. Minus v du. Well, as we saw when we integrated this guy last time, v du is going to have a negative sign, so minus and minus is a plus. I won't go through integrating v du other than to say v is f of t and du is e to the minus st dt. And the minus, a minus is a plus. Derivative of what's up top is minus s, and the minus cancels. Okay, so this guy here is the definition of the Fourier or the Laplace transform. This is f of s here. So if I integrate this out, I've got e to the minus st f of t evaluated at t equals infinity, as t goes to infinity, minus this evaluated at 0, e to the minus st f of t evaluated at t equals 0, plus s times f of s. Okay, well, this guy here, as t goes to infinity, it's 1 over e to the infinity, 1 over a very big number in a sense, that just goes to 0. And this guy is anything to the 0 is 1, and so I've got all that's left is f evaluated at 0. So I've got s f of s, s times f of s minus f evaluated at 0. Again, that e to the 0 goes to 1, so we're just left with f evaluated at 0, which is what we had in the properties.